Good morning, grade 10s. Today I want to talk to you about the difference between speed and velocity. Just like with distance and displacement, the difference comes down to vector versus scalar. Consider, for example, if you were going to drive from Brandon to Winnipeg. The distance between these two cities is about 200 kilometers. And from experience, you know that it takes us approximately 2 hours to get there. Our speed then would be 200 kilometers divided by 2 hours, or 100 kilometers per hour. When we say per hour, this is the divide sign. It means that in every 1 hour we traveled 100 kilometers. Because we had to travel for twice as much distance, it took us twice as much time. Speed is always calculated as distance divided by time. We do exactly the same thing if we want to talk about velocity, but velocity is a vector quantity. It lets us know that we were traveling 200 kilometers to the east. Because we traveled at 200 kilometers east in the same 2 hours, our velocity is also 200 kilometers divided by 200 divided by 2 hours gives us 100 kilometers per hour to the east. Realistically, the only difference between speed and velocity is speed is scalar and velocity is vector. Speed tells us how fast, velocity tells us how fast and in which direction. Speed and velocity don't always equal to the same number. Suppose that an object travels 2 meters to the east and then turns around and travels 2 meters to the west. Its total distance that it's traveled is 4 meters. Its displacement, however, is 0. The object ended up, or the person ended up, right back where it started. So it's traveled 0 meters over the same time period. Although its speed might be 4 meters per second, its velocity then is 0 meters per second. Yeah, it seems kind of confusing. I realize that an object can have speed but no velocity. But remember that velocity is based on displacement, how far you've ended up from your starting point. Whereas speed doesn't have that directional component. It talks about the total distance that you traveled over the same amount of time. You're also going to notice sometimes we talk about average speed or average velocity. If you consider driving from Winnipeg back to Brandon or Brandon to Winnipeg, you wouldn't assume that we drove the same speed or velocity of 100 kilometers per hour the entire trip. Obviously, we slowed down through Portage, and I doubt you backed out of your driveway at 100 kilometers per hour either. The results would be tragic. But overall, the average time that you took was 2 hours to cover that 200 kilometers, so you traveled on average 100 kilometers per hour. Average speed is a much more useful term when our speed might speed up or slow down as we move through different time zones. How do we calculate how much time has passed in a trip? I doubt when you travel from Brandon to Winnipeg that you set a stopwatch and time your time so that you know it takes exactly 2 hours. More likely, you look at a watch. You find what time you left at and what time you arrived at. Suppose, for example, that you left at 1 o'clock. We will call 1 p.m. our starting time, or T1. If you then arrived in Winnipeg at 3 p.m., that would be our end time, or T2. These are instances in time. They tell us the start point and the end point. To find out how much time elapsed in between, we will subtract. The difference between 3 p.m. your arrival time and 1 p.m. your start time is 2 hours. In this unit, you will probably hear us use the words speed and velocity relatively interchangeably. For the most part, there's going to be no practical difference. We're going to probably use velocity as a more useful method because we're going to be talking about not just speed, but direction. We want to know our displacement, how far we've moved, and also the change in time that it took us to get there. To practice calculating speed and velocity, an average speed, and average velocity, I'd like you to work on the problems given to you in Task 2 and Task 3 of your work booklet.